we'll discuss about the classification of the crystalline solids on the basis of the nature of binding forces. First, introduction. Most of the solid substances are crystallines in nature. For example, all metallic elements like iron, copper, silver, and non-metallic elements like sulfur, phosphorus, iodine, and compounds like sodium chloride, zinc sulfide, and naphthalene form crystalline solids. Crystalline solids are on the basis of the nature of the intermolecular forces or bonds that hold the constituent of the particles together. These forces are van der Waals forces, ionic bonds, covalent bonds, and metallic bonds. In this basis, we can classify into 4 categories: molecular, ionic, metallic, and covalent solids. So now we'll discuss first molecular solids. Molecules are the constituent particles of molecular solids. These are further subdivided into the following categories. Number 1, non-polar molecular solids and polar molecular solids. Now, non-polar molecular solids, what is this? They comprise either atoms, for example, argon, helium, or the molecules formed by the non-polar covalent bonds. For example, hydrogen gas, chlorine gas, means H2, Cl2, and I2 molecules. In this formation, the atoms or molecules are held by weak dispersion forces, or it is called the London forces. Whatever you already found in the class number 11's textbooks. The solids are soft and non-conductors of electricity. They have low melting points and are usually in liquids, gaseous states at room temperature and pressure. Now, polar molecular solids. The molecules of substance like hydrogen chloride, sulfur dioxide, etc. are formed by polar covalent bonds. Polar covalent bonds. And this is the polar molecular solids. The molecules in such solids are held together by relatively stronger dipole-dipole interaction. We have to remember this. These solids are soft and non-conductor of electricity. Their melting point is higher than those of non-polar molecular solids. Yet, most of these are gases or liquids under room temperature and pressure. Solid sulfur dioxide and solid ammonia are some examples of such solids. Now, hydrogen bonded molecular solids. What is this? The molecules of such solids contain polar covalent bonds between hydrogen atom and fluorine, oxygen, or nitrogen atoms. We know that the hydrogen bond is formed between the hydrogen atoms and the electronegative elements, fluorine, oxygen, and nitrogen atoms. Strong hydrogen bonding binds molecules of such solid like we know that H2O, water, it forms the ice with the help of the hydrogen bonding. and they are non-conductor of electricity. Generally, they are volatile liquids or soft solids under room temperature and pressure. Now, ionic solids. Ions are the constituent particles of ionic solids. Such solids are formed by three-dimensional arrangements of cations and anions. This is called the ionic solids by the strong Coulombic forces. These ionic solids are very hard but brittle in nature. They have high melting and boiling points. Since the ions are not free to move about, they are electrical insulator in solid state. In the molten state or when dissolved in water, the ions become free to move about and they conduct electricity. That means when ionic solids is in dissolved condition or molten state, then they conduct electricity because ions are freely movable. Here one general description is there. You can read this. Metals are orderly collection of positive ions surrounded by and held together by the sea of free electrons. These electrons are mobile and are evenly spread about throughout the crystal. Each metal atom contributes one or more electrons towards the sea of the mobile electrons. These free and mobile electrons are responsible for high electrical and thermal conductivity of metals. When an electric field is applied, these electrons flow through the network of positive ions. Similarly, when heat is supplied to one portion of the metal, the thermal energy is uniformly spread by the free electrons. Another important characteristic of metals is their luster and color in certain cases. This is due to the presence of the free electrons in them. Metals are highly malleable and ductile. Another general description is there. A wide variety of crystalline solids of non-metals result from the formation of covalent bonds between adjacent atoms throughout the crystal. They are also called the giant molecules. Covalent bonds are strong and directional in nature. Therefore, atoms are held very strongly at their position. Such solids are very hard and brittle. They have extremely high melting points and may even decompose before melting. They are insulator and do not conduct electricity. Diamond in this figure is in the book, NCERT books, and silicon carbides are typical examples of such solids. Although the graphite, another figure is given in the NCERT books, also belongs to this class of crystal, but it is soft and is a conductor of electricity. Its exceptional properties is due to its typical structure. Another description is there. Carbon atoms are arranged. Just these you have to read to understand. In different layers, and each atom is covalently bonded to 3 of its neighboring atoms in the same layer. The 4th valence electron of each atom is present between the different layers and free to move about. These free electrons make graphite a good conductor of electricity. Different layers can slide one over the other. This makes the graphite a soft solid and a good solid lubricant. Now we'll see in one table the classification of the crystalline solids. Types of solids. In the molecular solids, when it is non-polar, then constituent particles is the molecules, and bonding or attractive forces, dispersion or London forces. An example is the argon, carbon tetrachloride, hydrogen gas, iodine gas, and carbon dioxide gas, and its physical nature. For the molecular solid, in case of non-polar, it is soft, and conductivity, it is the insulator, and melting point is very low. For the polar molecular solids, its particle is the molecules, and forces is the dipole-dipole interaction. An example is already I told, the hydrogen chloride and sulfur dioxide, and physical nature is soft, it is insulator, and its melting point low. For the hydrogen bonded molecular solids, it consists of the molecules and its attractive force is hydrogen bonding. Example is the ice, that means H2O in ice form, solid form, and physical nature it is very hard, we know, and it is insulator, and its melting point also low. Now ionic solids. Ionic solids constituent particles is ion, and its attractive force is the Coulombic or electrostatic in nature. An example is the sodium chloride, magnesium oxide, zinc sulfide, and calcium fluoride, and its physical nature is hard but brittle. And electrical conductivity, insulator in solid state but conductor in molten state and in aqueous solution. And melting point is high. Now another crystalline solid is the metallic solids. It consists of the positive ions in a sea of delocalized electron, and in this case, example is the iron, copper, silver, and magnesium, and it is hard but malleable and ductile. Conductor in solid state as well as in molten state. Electrical conductivity and melting point is fairly high. Last case, covalent or network solids. It consists of the atoms, and attractive force or bonding is the covalent bonding. Example is the silica, SiO2, which is called quartz also, SiC, that means silicon carbide, and carbon as a diamond, in addition aluminum, and it is very hard physical nature, and it will act as an insulator, and melting point is very high. And same covalent and network solid is the graphite is there, and same it is bonded by the covalent bonding, but in its electrical conductivity it is a conductor, and it is the exception.